In this session, I just want to do a couple examples of solving log equations when the log part of the equation is not isolated yet. So for the first example, I want to look at the problem 4 log x equals 8. Okay, so typically what we do in a log equation is we take that log and we change it into exponential form. Okay, but to do that, the log has to be isolated first. So in this case, this part right here is the part that needs to be isolated. So what we would have to do first in this problem is we would have to divide both sides by 4 to get rid of that 4 out front. So those are going to cancel. And then you're going to have log x equals 2. At this point, we are ready to change it to an exponential equation. Remember that there's always a base, there's an exponent, and there's an argument. Your base is the part down here, and since there's nothing there, remember that's an understood 10. So that's our base. The 2 is our exponent. So we have base, exponent, and then the x is our argument. So when we change this into exponential form, it's going to say 10 raised to the second power equals x. And then at this point, all we have to do is evaluate 10 to the second power, or 10 squared, which we know is 100. And then you would always want to check your answers by taking that 100 and plugging it back into the original problem where the x is, and checking that you do actually get 8, your answer. Okay, let's look at another problem. Let's look at log 6x minus 3 equals -4. Okay, so in this case, again, your log is not isolated. Because there's no parentheses around that 6x minus 3, that minus 3 is not included in the log portion. The log portion is the log of 6x. So to solve this problem, we're going to have to first get rid of that minus 3 by adding 3 on both sides so that those cancel. So we get log of 6x equals -1. Okay, now we're ready to change it into exponential form. Remember, we have a base of 10 since there's nothing there. And then this is our exponent. And then the 6x is our argument. So when we change it into exponential form, it's going to be 10 raised to the -1 power equals 6x. And then we're just going to evaluate that. 10 to the -1 power is 1/10, or 0.1 equals 6x. And then we would need to divide by 6 on both sides because we're trying to get x by itself. And you get 1/60 in fraction form. And then again, you would want to take that 1/60 and plug it back into the x right here to see that you actually get -4 as your answer. And these types of problems also work with natural logs. If this was a natural log problem, then where I have base 10 right here, that would be a base e. So it would be e squared equals x. And that works for any base. It could be a base 10, it could be a base e, it could be a base 7. And you would still solve these problems in the same way.